Subscribe to our channel, and hit the bell icon, to never miss a video from us. Hi, welcome to this beginner's tutorial on AWS. This tutorial is ideal for those who wants to get started with AWS, and also ideal for candidates who wants to prepare for the Cloud Practitioner Certification exam. Amazon Web Services right now is the most extensive cloud services provider in the world, with more than 175 fully featured services. AWS is a broadly adopted cloud platform by developers, businesses, and enthusiasts of technology. AWS has a simple interface. When you log into the AWS, you will see this management console, and can see the services offered in various categories. The table here shows an overview of the developer's tool in AWS. You can automate service management with scripts using the command line. You can write, run, debug and deploy applications using an IDE. And you can also use software development kits. On AWS, you can easily develop applications in the programming language of your choice. Before we dive into AWS further, and learn more about their services, it is important to learn about the ideal way of building cloud solutions. AWS has developed an ideal framework to build cloud applications, which is called 5 Pillars of AWS Well-Architected Framework. The 5 pillars consist of the following areas. 1. Security. 2. Performance efficiency. 3. Reliability. 4. Operational excellence. And 5. Cost optimization. In the security pillar, we use a model of zero trust, while thinking about security in the cloud. All application components and services are seen as potentially malicious entities. The performance efficiency pillar focuses on efficiency and scalability. With cloud, you can handle any amount of traffic, and you need to choose and configure your services with scale in mind. The reliability pillar focuses on building services with resiliency to both service and infrastructure disruptions. Thus it is required that you architect your services with reliability in mind. The next pillar of operational excellence focuses on continuous improvement. We can think of it in terms of automation and eliminating human error. Cost optimization means achieving business outcomes while minimizing costs. Cost optimization in the cloud can be explained in terms of OpEx instead of CapEx. Let's have a quick brief on these pillars. 1. Security pillar. When we start thinking of security in terms of zero trust, we need to apply security measures at all levels of our system. The following are 3 important concepts involved in securing systems with zero trust in the cloud: identity and access management, network security, and data encryption. 2. Performance efficiency. In the on-premises model of doing things, servers are expensive, and often manually deployed and configured. It could take weeks, and each server is unique and require a lot of maintenance. In this model, it is quite common to use the same type of server, or even the same server, for multiple workloads. The better way is provisioning a cheap and quick solution, which also has freedom to select the server type that most closely matches the workload. And because every server is interchangeable and quick to deploy, we can quickly scale our capacity by adding more servers. The 2 concepts for performance efficiency are selection and scaling. Selection means the ability to choose the service with alignment to your workload. AWS has over 175 services in 24 categories. Achieving performance through selection means being able to choose the right tool for the job. While choosing the right service is key to getting started, choosing how it scales is important to continued performance. AWS has 2 primary means of scaling: vertical scaling and horizontal scaling. Vertical scaling involves upgrading your underlying compute to a bigger instance type. Horizontal scaling involves increasing the number of underlying instances. 3. Reliability. When thinking about reliability in the cloud, we can think in terms of blast radius, which means the maximum impact that might be sustained in the event of a system failure. To build reliable systems, you should focus on minimizing the blast radius of any individual component. 4. Operational excellence. The more operations that can be automated, the less chance there is for human error. In addition to preventing error, automation helps you continuously improve your internal processes. 5. Cost optimization. Cost optimization in the cloud can be explained in terms of OpEx instead of CapEx. OpEx is an ongoing, pay-as-you-go model, whereas CapEx is a one-time purchase model. OpEx model fundamentally changes the approach to costing. Instead of large upfront fixed costs, you are able to think in small ongoing variable expenses. Let's now look at the global infrastructure of AWS. AWS Cloud resources are hosted in multiple locations worldwide. These locations are composed of AWS regions, availability zones, and local zones. Each AWS region is a separate geographic area. Each AWS region has multiple, isolated locations, known as availability zones. And then you have local zones. By using local zones, you are able to place cloud resources in multiple locations, closer to your end users. A local zone is an extension of a region that is in a different location from your region. It is ideal for running latency-sensitive applications, local to end users, and resources in a specific geography. Resources aren't replicated across regions, unless you specifically choose to do so. AWS has state-of-the-art, highly available data centers. Although rare, failures can happen, affecting the availability of resources that are in the same location. If you host all of your resources in a single location that is affected by a failure, none of your resources would be available. Using a local zone, you can place select services closer to your end users. Next topic, AWS Compute and Amazon Elastic Compute Cloud. With AWS Compute Service, you can perform all types of computing tasks. With AWS Compute, you can develop, deploy, run and scale your applications and workloads in a secure environment. Some of the major service offerings under AWS Compute are Amazon Elastic Compute Cloud, Amazon Lightsail, AWS Lambda, EC2 Spot Instances, EC2 Auto Scaling, and AWS Elastic Beanstalk. Let's learn about these services in detail. Amazon EC2. Providing you with scalable computing capacity, Amazon EC2 eliminates your need to invest in hardware up front. You can use Amazon EC2 to develop and deploy applications faster, and launch as many, or as few virtual servers as you need. Amazon EC2 enables you to scale up or down, as your requirements change, for example, in cases of spikes in traffic on your website. Features of Amazon EC2. EC2 is basically Amazon's virtual machine. It offers virtual computing environments, which are known as instances. EC2 has both Windows and Linux-based instances. There are pre-configured templates for your instances, known as Amazon Machine Images. It has various configurations of CPU, memory, storage, and networking capacity for your instances. These are known as instance types. For security, it uses key pairs for secure login information for your instances. You get storage volumes for temporary data, known as instance store volumes. You get multiple physical locations for your resources. And a secure firewall. A static IPv4 addresses for dynamic cloud computing. And metadata, known as tags, that you can create and assign to your Amazon EC2 resources. And virtual networks, isolated from the rest of the AWS cloud, which can be optionally connected to your own network, known as virtual private clouds. Let's take a look at Amazon EC2 basic infrastructure. First is Amazon Machine Image and Instances. An Amazon Machine Image is a template that contains a software configuration, for example, an operating system, an application server, and applications. From an AMI, you launch an instance. An instance is a virtual server in the cloud, which is a copy of the AMI that you specified when you launched the instance. You can launch multiple instances of an AMI. You can also create your own custom AMI, or AMIs. Doing so enables you to quickly and easily start new instances that have everything you need. Next is Amazon EC2 instance types. It is important to know your use case well before launching an instance. AWS offers instance types optimized to fit different use cases. 1. General purpose instances. These instances provide a balance of compute, memory and networking resources, and can be used for a variety of diverse workloads. These instances are ideal for applications that use these resources in equal proportions, such as web servers and code repositories. 2. Compute-optimized instances. Ideal for compute-bound applications that benefit from high-performance processors. Instances belonging to this family are well suited for batch processing workloads, media transcoding, high-performance web servers, high-performance computing, scientific modeling, and dedicated gaming servers. 3. Memory-optimized instances. These instances are designed to deliver fast performance for workloads that process large datasets in memory. 4. Accelerated computing instances. These instances use hardware accelerators, or coprocessors, to perform functions, such as floating point calculations, graphics processing, or data pattern matching, more efficiently. 5. Storage-optimized instances. These instances are designed for workloads that require high sequential read and write access to very large datasets on local storage. They are optimized to deliver tens of thousands of low-latency, random I/O operations per second to applications. Now, we will learn how to launch an EC2 instance on AWS. We'll learn to launch both Windows and Linux-based instances. We'll first log into our AWS Management Console, and then select the EC2 service here, given under the Compute category. This will take us to the EC2 dashboard. To begin, click on Launch Instance. After that, you will be shown a bunch of AMIs. You can see there are many operating systems options, which you can select to be run in your server. You can launch a Linux-based instance, or a Windows-based instance. In this exercise, we will be launching a Linux, as well as a Windows-based server. Here we'll be selecting the free tier eligible instance, which means you will not be charged for practicing launching an instance. Now let's first select the Ubuntu server here. It will show a lot of servers, with options for number of CPUs, memory etc. But we will select this free tier eligible one here, named T2.micro. Then click on Next. And it will show you all these details. Do not worry about these, and just leave them as it is. Click Next. It will then ask you about how much storage, or hard drive space you want. By default it's 8 GB. If you want you can change this, we will leave it as it is. Then next, you can add tags for your instance. Tags are nothing but metadata. For example, you can add a name to the instance, a department, purpose, anything you want. Click Next and then we will be shown the option for the security group. It is kind of a firewall, means what kind of connection is allowed here. So here we see that an SSH connection is allowed. Here you can give the option of who can use this instance. If you want it to be used by anyone, you can select anywhere. This is helpful when IP addresses of your computer is not fixed, so you can access it from anywhere. If you have one IP, you can select My IP, and then only this IP will be allowed to access this instance, using SSH protocol. Now click on Review and Launch. Now we will create our key pair, for security purposes, so that no one without this key can access this instance, even if they have the IP address. Let's create a new key pair, give it a name, and download the key pair. This will download as a PEM extension. Now click on Launch Instance. You can click here, and go to the instance. You can see the state of the instance, as pending or running. It will be in the running state shortly. Now it is in the running state. You can see all the details of the instance in the panel below. Now how will we use this instance? We need to connect to our instance. To connect to a Linux instance, there is a software we use, called PuTTY. In Google, search, download PuTTY. Download these two files here. The PuTTY software is used to launch the instance, and for using your PEM key pair file, PuTTYgen is used. Download these and install the PuTTY software. Now, you need to convert that PEM key pair file into PPK file, to use the key pair with PuTTY, to launch the Linux instance. So open the PuTTYgen, load your PEM file. and then save it as PPK file by clicking on Save Private Key. Next you need to launch the PuTTY software. Mention the IP address for your instance, which is shown here on your instance panel. Now click on SSH. Click on Auth. Click Load to load the PPK file, and click Open. If a PuTTY security alert like this pops, click Yes. Now you will see this screen saying, Login as. Write Ubuntu here, since you are trying to launch an Ubuntu instance. It will verify the key. And now you are logged into your Ubuntu server. Next, we will launch a Windows instance. Windows is a graphic interface-based operating system, so, for launching a Windows server, you don't use PuTTY. Instead, you get a remote desktop connection file, also called RDP file, and use that to log into your Windows instance. Now, to launch a Windows instance, click on Launch Instance. Select the free tier eligible Windows operating system. Click on Next, leave the details as it is, and click on Next again, to reach the Security Group panel. Here you can see that instead of SSH, you have RDP. Select Launch. And, we will select the same key pair. Then we will launch instance. Our instance is launched, and for now in pending state. Wait for it to be in running state. Select your instance, then click on Actions, and select Connect. You can download your RDP file from here. Then select Get Password. Load your PEM file. Then select Decrypt Password, and you will be given your password. Once you get your password, click on your downloaded RDP file to launch the Windows instance, and enter the password. If it prompts this message that remote computer cannot be verified, just click Yes. And now you are logged into your Windows server. You can do anything you want on this. You can install a software here, or make it a database server. So this is how you launch an EC2 instance on AWS. Next popular and main service in AWS, is Amazon Lightsail. Lightsail is the easiest way to get started with AWS. It has everything you need to get your project running in the cloud. Lightsail includes everything you need to launch your project quickly. It has a virtual machine, a managed database, SSD-based storage, data transfer, DNS management, and a static IP, for a low, predictable monthly price. You can also scale your application or website over time, and improve its availability and redundancy, by adding other Lightsail resources. Lightsail allows you to use bigger instances to scale performances, add load balancers, connect multiple Lightsail instances, run instances across multiple availability zones, peer your VPC, so that your Lightsail instances can use other AWS resources outside of Lightsail. Lightsail is best suited to projects that require a few dozen instances or less. You can create pre-configured virtual private servers, that include everything, to easily deploy and manage your application, or create databases, for which the security and health of the underlying infrastructure, and operating system, is managed by Lightsail. Lightsail is for developers. You can choose an image for your Lightsail instance, that jumpstarts your development project, so you don't have to spend as much time installing software or frameworks. Lightsail is commonly used for development projects, running websites, web applications, business software, blogs, e-commerce sites, and more. Everything you do in the Lightsail console is backed by a publicly available API. Lightsail offers a range of operating system and application templates that are automatically installed when you create a new Lightsail instance. Application templates include WordPress, Django, Drupal, Node.js, etc. Amazon EC2 Spot Instances. A Spot instance is an unused EC2 instance that is available for less than the on-demand price. Using Spot instances, you can lower your Amazon EC2 costs significantly. Combine Spot instances with reserved instances and on-demand instances using EC2 Auto Scaling to optimize workload cost with performance. The hourly price for a Spot instance is called a spot price, and the spot price of each instance type in each availability zone is set by Amazon EC2 and adjusted gradually based on the long-term supply of and demand for Spot instances. Spot instances are a cost-effective choice if you can be flexible about when your applications run, and if your applications can be interrupted. For example, Spot instances are well suited for data analysis, batch jobs, background processing, and optional tasks. You can use Spot instances for various stateless, fault-tolerant, or flexible applications such as big data, containerized workloads, high-performance computing, HPC, and other test and development workloads. For using Spot instances, you choose all instances and availability zones that works for your workloads, then choose your interruption behavior, and then launch and scale your target capacity. It is beneficial to follow best practices for using Spot instances. 1. Be flexible about instance types. Test your application on different instance types when possible. Because prices fluctuate independently for each instance type in an availability zone, you can often get more compute capacity for the same price when you have instance type flexibility. 2. Choose pools where prices haven't changed much. Because prices adjust based on long-term demand, and popular instance types tend to have more price adjustments. Therefore, picking older generation instance types that are less popular tends to result in lower costs and fewer interruptions. Similarly, the same instance type can have different prices in different availability zones. 3. Minimize the impact of interruptions. Amazon EC2 Spot's Hibernate feature allows you to pause and then resume Amazon EBS-backed instances when capacity is available. You can also stop or terminate your Spot instances when EC2 reclaims the capacity back with 2 minutes of notice. One strategy to maintain a minimum level of guaranteed compute resources for your applications is to launch a core group of on-demand instances and supplement them with Spot instances when the opportunity arises. Another strategy is to launch Spot instances with a specified duration, which are designed not to be interrupted and will run continuously for the duration you select. Amazon EC2 Auto Scaling. Auto scaling ensures the availability of the correct number of EC2 instances to handle the load for your application. You can create collections of EC2 instances, called auto scaling groups. You can specify the minimum and maximum number of instances in each auto scaling group, and Amazon EC2 Auto Scaling ensures that your group never goes below the minimum and above the maximum size. If you specify the desired capacity, Amazon EC2 Auto Scaling ensures that your group has this many instances. If you specify scaling policies, then Amazon EC2 Auto Scaling can launch or terminate instances as demand on your application increases or decreases. Auto scaling components. The following are the key components of auto scaling. 1. Groups. Your EC2 instances are organized into groups so that they can be treated as a logical unit for the purposes of scaling and management. When you create a group, you can specify its minimum, maximum, and desired number of EC2 instances. 2. Configuration templates. Your group uses a launch template or a launch configuration as a configuration template for its EC2 instances. You can specify information, such as the AMI, ID, instance type, key pair, security groups, and block device mapping for your instances. 3. Scaling options. Amazon EC2 Auto Scaling provides several ways for you to scale your auto scaling groups. For example, you can configure a group to scale based on the occurrence of specified conditions or on a schedule. AWS Elastic Beanstalk. With Elastic Beanstalk, you can quickly deploy and manage applications in the AWS Cloud without having to learn about the infrastructure that runs those applications. Elastic Beanstalk reduces management complexity without restricting choice or control. You simply upload your application, and Elastic Beanstalk automatically handles the details of capacity provisioning, load balancing, scaling, and application health monitoring. Elastic Beanstalk supports applications developed in Go, Java, .NET, Node.js, PHP, Python, and Ruby. When you deploy your application, Elastic Beanstalk builds the selected, supported platform version, and provisions one or more AWS resources, such as Amazon EC2 Instances, to run your application. AWS Lambda. AWS Lambda is the serverless computing service by AWS. Serverless computing is a cloud computing execution model, in which the cloud provider runs the server, and dynamically manages the allocation of machine resources. You can focus on your core product and business logic, instead of responsibilities like operating system, access control, OS patching, provisioning, right-sizing, scaling, and availability. The platform manages these responsibilities for you. AWS Lambda lets you run code without provisioning or managing servers. AWS Lambda executes your code only when needed, and scales automatically, from a few requests per day, to thousands per second. You pay only for the compute time you consume. There is no charge when your code is not running. With AWS Lambda, you can run code for virtually any type of application, or backend service, all with zero administration. Lambda is a high-scale, provision-free serverless compute offering based on functions. Lambda functions can be triggered by a variety of events that occur on AWS, or on supporting third-party services. They enable you to build reactive, event-driven systems. Lambda can be described as a type of serverless, function-as-a-service. It is one approach to building event-driven computing systems. It relies on functions as the unit of deployment and execution. In serverless FaaS model, no virtual machines or containers are present in the programming model, and the vendor provides provision-free scalability and built-in reliability. AWS Lambda automatically scales your application by running code in response to each trigger. Your code runs in parallel and processes each trigger individually, scaling precisely with the size of the workload. AWS Containers. Containers are a form of operating system virtualization. Containers are an executable unit of software, in which application code is packaged, along with its libraries and dependencies. Containers are small, fast, and portable, because unlike a virtual machine, containers do not need to include a guest operating system in every instance, and can, instead, simply leverage the features and resources of the host operating system. Instead of virtualizing the hardware stack, as with the virtual machines approach, containers virtualize at the operating system level, with multiple containers running atop the OS kernel directly. This means that containers are far more lightweight. They share the operating system kernel, start much faster, and use a fraction of the memory, compared to booting an entire operating system. Amazon Elastic Container Registry. Amazon ECR is a managed AWS Docker registry service that is secure, scalable, and reliable. Amazon ECR supports private Docker repositories with resource-based permissions using AWS IAM, so that specific users or Amazon EC2 instances can access repositories and images. Developers can use the Docker CLI to push, pull, and manage images. Components of Amazon ECR. Amazon ECR contains the following components. Registry. An Amazon ECR registry is provided to each AWS account. You can create image repositories in your registry and store images in them. Authorization token. Your Docker client must authenticate to Amazon ECR registries as an AWS user before it can push and pull images. Repository. An Amazon ECR image repository contains your Docker or Open Container Initiative images. Repository policy. You can control access to your repositories and the images within them with repository policies. Last is image. You can push and pull container images to your repositories. You can use these images locally on your development system, or you can use them in Amazon ECS task definitions and Amazon EKS pod specifications. Amazon Elastic Container Service. Amazon ECS is a highly scalable, fast, container management service that makes it easy to run, stop, and manage Docker containers on a cluster. ECS is a great choice to run containers. You can choose to run your ECS clusters using AWS Fargate, which is a serverless compute for containers. Fargate removes the need to provision and manage servers. It lets you specify and pay for resources per application, and improves security through application isolation by design. You can host your cluster on a serverless infrastructure that is managed by Amazon ECS. For more control, you can host your tasks on a cluster of Amazon Elastic Compute Cloud Instances. Amazon ECS lets you launch and stop container-based applications with simple API calls, allows you to get the state of your cluster from a centralized service, and gives you access to many familiar Elastic Compute Cloud features. Amazon Elastic Kubernetes Service. Run Kubernetes on AWS easily, without needing to maintain your own Kubernetes control plane. Kubernetes is an open-source system for automating the deployment, scaling, and management of containerized applications. The secure and highly available configuration of Amazon EKS makes it reliable and recommended for production workloads. AWS Storage. With AWS Storage, store and retrieve any amount of data, anytime, from anywhere on the web. AWS offers highly scalable, reliable, fast, and inexpensive data storage service, making it easier for developers to execute web-scale computing. First is Amazon Simple Storage Service, or Amazon S3. Amazon S3 is an object storage service with industry-leading scalability, data availability, security, and performance. It can be used by customers of all sizes and industries to store and protect any amount of data. Amazon S3 can be used for a range of use cases, such as websites, mobile applications, backup and restore, archive, enterprise applications, IoT devices, and big data analytics. Amazon built S3, with minimal features intentionally. Amazon S3 service is focused on simplicity and robustness. Let's look at the components involved in S3. 1. Buckets. Buckets are fundamental containers in Amazon S3 for data storage. You can create a bucket and name them. 2. Object. Object are fundamental entities stored in Amazon S3. They consist of object data and metadata. 3. Storage. You can store an infinite amount of objects in a bucket. Each object can contain up to 5 terabytes of data. 4. Keys. Each object uses a unique developer-assigned key. 5. Permissions. Grant or deny access to others, for uploading or downloading data into your Amazon S3 bucket. 6. Region. Choose the region where Amazon S3 will store the buckets, to optimize latency, minimize costs, or address regulatory requirements. 7. Interface. Work with any Internet Development Toolkit, with standards-based REST and SOAP interfaces. 8. Pricing. S3 charges you only for what you actually use. There are no hidden costs. Amazon S3 Access Points simplifies managing data access at scale for applications using shared datasets on S3. With S3 Access Points, you can now easily create hundreds of access points per bucket, representing a new way of provisioning access to shared datasets. Access points provide a customized path into a bucket, with a unique host name and access policy that enforces the specific permissions and network controls for any request made through the access point. Amazon S3 offers a range of storage classes, designed for different use cases. These include S3 Standard, for general-purpose storage of frequently accessed data. S3 Intelligent Tiering, for data with unknown or changing access patterns. S3 Standard Infrequent Access, and S3 OneZone Infrequent Access, for long-lived, but less frequently accessed data. And Amazon S3 Glacier, and Amazon S3 Glacier Deep Archive, for long-term archive and digital preservation. Amazon S3 also offers capabilities to manage your data throughout its life cycle. Once an S3 lifecycle policy is set, your data will automatically transfer to a different storage class without any changes to your application. AWS Networking. AWS offers networking capabilities required to run any workload in the cloud, with security, availability, performance, global coverage, and manageability. First is Amazon Virtual Private Cloud. With Amazon Virtual Private Cloud, you can launch AWS resources into a virtual network that you define. This virtual network closely resembles a traditional network operated in a private data center of your own. with the benefits of using the scalable infrastructure of AWS. Amazon VPC is the networking layer for Amazon EC2. The following are the key concepts for VPCs. A virtual private cloud is a virtual network, dedicated to your AWS account. It is logically isolated from other virtual networks in the AWS cloud. You can launch your AWS resources, such as Amazon EC2 Instances, into your VPC. You can specify an IP address range for the VPC, add subnets, associate security groups, and configure route tables. A subnet is a range of IP addresses in your VPC. You can launch AWS resources into a specified subnet. Use a public subnet for resources that must be connected to the internet, and a private subnet for resources that won't be connected to the internet. A route table contains a set of rules, called routes, that are used to determine where network traffic is directed. An internet gateway is a horizontally scaled, redundant, and highly available VPC component that allows communication between instances in your VPC and the internet. It therefore imposes no availability risks or bandwidth constraints on your network traffic. A VPC endpoint enables you to privately connect your VPC to supported AWS services and VPC endpoint services, powered by private link without requiring an internet gateway, NAT device, VPN connection, or AWS Direct Connect connection. Instances in your VPC do not require public IP addresses to communicate with resources in the service. Traffic between your VPC and the other service does not leave the Amazon network. Next is Elastic Load Balancer. A load balancer distributes workloads across multiple compute resources, such as virtual servers. Using a load balancer increases the availability and fault tolerance of your applications. You can add and remove compute resources from your load balancer as your needs change, without disrupting the overall flow of requests to your applications. Elastic Load Balancing distributes incoming application or network traffic across multiple targets, such as Amazon EC2 instances, containers, and IP addresses, in multiple availability zones. Elastic Load Balancing scales your load balancer as traffic to your application changes over time. It can automatically scale to the vast majority of workloads. You can configure health checks, which monitor the health of the compute resources, so that the load balancer sends requests only to the healthy ones. You can also offload the work of encryption and decryption to your load balancer, so that your compute resources can focus on their main work. Elastic Load Balancing supports three types of load balancers: classic load balancers, application load balancers, and network load balancers. Classic Load Balancer provides basic load balancing across multiple Amazon EC2 instances, and operates at both the request level and connection level. Classic Load Balancer is intended for applications that were built within the EC2 Classic network. Application load balancers are best suited for load balancing of HTTP and HTTPS traffic, and provides advanced request routing, targeted at the delivery of modern application architectures, including microservices and containers. Network load balancers are best suited for load balancing of transmission control protocol, user datagram protocol and transport layer security, traffic where extreme performance is required. Next, Amazon Route 53. Amazon Route 53 is a highly available and scalable DNS web service. Route 53 is used to perform three main functions in any combination: domain registration, DNS routing, and health checking. It is designed to provide an extremely reliable and cost-effective way to route end users to internet applications. Amazon Route 53 connects user requests to infrastructure running in AWS, and can also be used to route users to infrastructure outside of AWS. It can also be used to configure DNS health checks, to route traffic to healthy endpoints, or to independently monitor the health of an application and its endpoints. For more such videos, subscribe to our channel.